My name's David Gagne. I've been with ITASCA for about 18 years. My background is mining engineering, but did consulting for a number of years, and now I'm responsible for our technical marketing, mainly for software. So today I'd like to introduce you to fish scripting. So, introduction to fish scripting. So, fish is actually just a short form of FLAC-ish. So back in the 80s when ITASCA software was being created, it was recognized that there was a desire for a scripting language. And essentially the ability to interact, manipulate, and control the actual models, the zones, particles, whatever you're working with. And so the FLAC was the first of our software to have a scripting language, and so fish is born of FLAC-ish. Essentially, fish scripts are lines of code embedded in a data file. Gives you control of most aspects of your model before, after, and even during cycling. So sometimes you might want to inspect a zone each step, see what it's doing. Maybe it's yielded, maybe you want to change some properties because of that. It's a lot of looping, because if you have to loop through hundreds or thousands or millions of zones in a model every step, you can imagine that that can add up in terms of time. So with fish, we can parameterize data files, sensitivity studies, we can automate repetitive work, add custom physics. So Derek actually added in PFC a buoyancy fish function that let particles sort of float on imaginary water. So these are all things that can be done, even though we haven't necessarily added buoyancy to something like PFC. You can. It also lets us record the history of any fish variable over the model runtime. That can be useful if you want to compare it to, say, sensors that you have in the field. Essentially, when you start a data file, and I imagine you guys in the last day and a half have done some models, run them, added zones. So essentially what you're working with is, in a data file, the assumption is that those are commands or comments. And so in order to specify that we're going to be using fish scripting, we have to use this command called fish, define, and then almost any name that your heart desires. So that's just the function name. It's important to end the function so that it knows that anything after that point are commands again. So you can kind of think of them as parentheses in a sense. Within a fish function, we can include commands, zone property, assign some properties. And then this is just within a command, we actually can use these, what are called fish fragments, which can just be variables, or they could be calculations. And essentially, we designate those with these square brackets. So it's almost like you're in a calculator mode, if you will, within a command. And that way we can add variables to commands, and it gives us a little more flexibility. In order to call the function, we simply call the function name within one of these fish fragments. If you're used to older fish, you might have seen like an ampered sign, like an @ symbol, and that's now essentially obsolete. So the proper way to call a fish function is using one of these fish fragments with the function name in the brackets. Functions can call other functions and so forth. You have to define a function before you can call it. I guess that makes sense. Fish functions and the current values associated variables are saved only when you save the model. So you don't save a model state, but you save just the project and you close it down. You lose the current value of the fish variables or functions. You can simply rerun them, no problem. But generally speaking, we want to be saving periodically to capture and retain those values, especially if you're tracking a history. As with all programming, you essentially want to create your fish functions in an incremental fashion. So one of the worst things to do is sort of sit down, write dozens of lines of code or hundreds of lines of code, and then hit run. It's better to sort of build it up gradually. and then test as you go along. Anything following a semicolon, you can see here, this is an example of a data file. We have a mixture of commands and a fish function here. Anything that follows a semicolon, and it'll be noted as a gray coloring, is a comment. And encourage you to add comments. It's a good way to remind you, maybe what that variable means or what that part of the program is doing, or the project, I should say. And so anything after a semicolon that appears gray, essentially FLAC2D will just ignore. It could be something as simple as, this is designed for this metric or this unit set. So I'm using meters and meters per second and kilograms per cubic meter, so that when you go to run it, you don't all of a sudden start putting in imperial units. It's all sorts of fish variables, booleans, numbers, strings, lists, matrices, maps, tensors, vectors, etc. Function name or a variable must start with a non-number and must not contain any of these reserved symbols. There are also some reserved names. So you can't, for example, have a fish function called cycle, because that could confuse the software. Cycle is a reserved command. By and large, though, it's pretty flexible. And if you really wanted something called cycle, you could always use like a underscore symbol at the start or the end. The functions and variables are not case sensitive. So Fred with a capital F equals Fred with all lowercase symbols. There's two main classes of variables, global and local. By default, unless you've changed any of the settings under your options, all variables are treated to be global. And what that just means is that you can access them everywhere. If you want, you can specify a local variable, and that value of that variable and the variable itself only lives within that function. An advantage of that is it could be sort of a junk variable, like a counter or something like that, or it could be very important, and you don't necessarily want to change that value from another function. So if you've got a global variable Fred and you have it in two functions, that value will change depending on the function that you've called. Sometimes it's useful to have a local variable. When you're creating a new data file, there are two places to go from. You can either go to the select content dropdown, new data file, add plots, etc. Or you can go under file, new, and data file, or Control N if you prefer keyboard shortcuts. Once you've created a data file, it'll appear here in the left-hand column amongst other data files or save files or geometry files, and you just have to double click them to open them. You can also find them through the drop-down, and if you double click there, it'll load it. Note that it'll load it in the active space. So when I do a project, I kind of like to have my data file on the left, then I split it, make a plot on the right. So I've kind of got an input side and an output side. But if I happen to be clicked on the plot and I then open the data file, it's going to open up on top of that plot. That always catches me off guard with the new layout. So we have this text editor that we'll play with. It's built in because obviously commands and fish functions are really a big part of our software. So we have a really good quality text editor. You notice that the color changes depending on what the item is. If it's a variable, it's a command. If it's string, if it's a number with a value, these colors all change. We have all sorts of options for manipulating it. And one thing that's quite nice, especially if you're testing a model as you're building it and running it, you want to see what the value of your global variables are. There is this global symbol list that gets populated, and you can copy these values. They'll change while the model's cycling if something changes with cycling. So you can see it sort of in live time. And just to note, as of the next release that goes out, I think we're using 158, so 159, they actually moved that down here where the Python and the lists get generated on these tabs. So it won't be here anymore, it'll be down here. When you're editing in the text editor, you'll see a number of icons in the menu. So we can create a new data file, we can open, save, we can close. You can find and replace text. You can comment whole sections. And so this is useful if you've got hundreds of lines of commands and fish, and you want to sort of turn off part of your model and run it. You can highlight every line, and then you just click on the comment section, and it'll all get grayed out. The alternative is you can just type a bunch of semicolons, kind of arrow down, but that's the short way to do it. The text editor has a number of options. So under Tools, Options, you'll see an editor entry. And this is just if you want to customize. So we can change the font, the size of the font. Maybe you prefer sort of a dark background. Maybe you're nostalgic and you like a green text on a black background. Whatever you prefer, you can set that up. It'll remember it. And you can go from there. A couple things in the documentation. Fish is kind of spread around a couple of sections. So there's a common fish, and this is something that's common to all the software. So that's stuff like, what do we have? Geometry, groups, histories, and things like that. And you'll find that under the main ITASCA software guide heading under common commands and fish. There are also a number of fish utility functions that are built in, and you'll find that under scripting, fish scripting reference, and under fish functions. And these are things like input-output utilities if you want to display something on the screen, mail utilities, say you want the program to email you after some model's been running for 20 hours and you want to have it attach a plot. You can do that all through these utility files. And then under the model section, so if you're in FLAC2D, you can go to FLAC commands, fish, and workspaces. Then under zone and fish functions, you'll see a whole bunch of zone functions or grid point functions. And this is things like if you wanted to delete a zone, create a zone all through fish, find out what the area is, extra variables, different things like that. So, and in your PDF that you'll get, there's hyperlinks to all those sections in each of these pages at the top.